All right, so this is the rest of 2, 5. Okay, and we're going to use a little shortcut to make our life easier to divide. Okay, so before I actually show you, yeah. Factor and remainder. This is the big title. But before we do this, I'm going to show you the shortcut division, which we call synthetic division. Like synthetic oil. Yes. When we talk about doing synthetic division, it only works in one scenario. And that is when you divide. What my eyes never pick up, I don't understand. When you divide by x plus or minus some number, okay? The x cannot have an exponent on it. It cannot have a coefficient in front. It can't have more than 2 pieces by what you're dividing by. So the warm-up that you had this morning, x cubed minus 3x squared minus 5x minus 25 divided by x minus 5 would satisfy that criteria, right? Because it was, write it on here for the people watching the video, which is probably going to be a lot since they're calling for pictures and stuff. So. No, you don't have to rewrite it. Well, probably because we're actually going to divide it synthetically, sorry. All right, so if you notice, I'm dividing by just x. If that was x squared minus 5, it wouldn't work. If that was 2x minus 5, it wouldn't work, okay? But x minus 5 or x plus 5, either one of those work, okay? So when we set it up, here's what we do. We take this number, but we change the sign. So it'd be positive 5. We're going to do an upside down division sign. Ah! And now we're going to, this row is going to be the coefficients of what we're dividing, including any placeholders we may need. So, remember there's a 1 if there's not one there. 1 forward. All right, 1, what's the next coefficient? Negative 3. Then negative 5. Then, okay, all the coefficients of what you're dividing, okay? And the number goes on the outside with the opposite sign. Now, here's the pattern. Y'all ready for it? Drop the first one. Multiply. 5 times 1 is
5.
And add the column.
Add the what?
Oh, no. Okay.
This is plus. What's negative 3 plus 5?
2.
2. Now repeat. 5 times 2 is negative 5 and 10 is again. 5 times 5 is negative 25 and 25 is. When you divided this long division, it took a while, but you got x squared plus 2x plus 5. Did you not? What's the relationship?
1x, 2x.
Mm-hmm. This last column is my remainder column. Then I have my constant. Then this is x squared. If I had another one, what do you think it would be? X to the third. X to the fourth.
Yeah, I like the long division.
So you like it better because it makes more sense, but we're going to be testing things soon where you'll have to find which one gives you a remainder of 0. So you may have to divide 6, 7 different things before you find the right one. You see what I'm saying? And these get to be so quick, you can do this faster than you can do that.
So you can only do this when you have that x by itself.
That.
Oh, wait.
So that's
it'll
what
always
we
be x
use.
squared and then x.
No. Everybody always says that. They say, I'm just going to stick with long division. And then you watch it enough and you go, yeah, I'll do synthetic.
Yeah, like I started to think about it, it's not as hard as you think.
It's not. Watch several of them and it's quite easy. Let's do another one. Let's do...
Go back.
Oh, go back.
Oh, no, I meant please.
Let's do x to the third minus x squared plus 4x minus 10 divided by x plus 2 this time. So first question is, can I divide it synthetically? Yes. Why? It doesn't have a coefficient or exponent, it's just x plus a number, right? Or x minus a number. Either one works. All right, so what I want to do is I want to set up my synthetic division. What goes outside? Close. -2. Upside down parentheses, and now I need all coefficients. This is imperative that you include placeholders, because if you don't, then it doesn't work, okay? All right, so what are the coefficients? 1. Tatiana, I'm going to have to make you sit up. If you're that sick, you have to go home. I can send you to the nurse. Why don't you go to the nurse and let her check your temp? All right, give me the rest of them. -1. -4. I'm sorry. I know you don't feel well. And -10. All right, drop down the first one. Multiply. -2.
-1
plus -2 is -3.
Oh my god.
-2 times -3 is 6. That's 10. And this is right. So now let's interpret this answer. When you divide these two, remember, this is remainder, constant, x squared. Then you get x squared minus 3x plus 10. And this is where you can do the plus or the minus because it's negative. -30 over what you divide it by. Because that's the way remainder works, right?
Okay, wait, will it always be? Wait, so it'll always be
Yes.
x squared and then x and then constant? Like there will never be an x cubed?
It could be, so
If you have an
you look, if you have another column here, it would be an x to the third. Yes, you're exactly right, Wills. If you started with an x to the fourth here, you'd end up with an x to the third when you divided. Uno mas.
I don't speak.
It
Wait,
doesn't look like just.
Wait, so what if it does?
It doesn't work, you have to divide it.
You got to do long division.
Wait, so there's a chance it might not work?
Well, so sometimes you have to divide, and you have to determine if you do long division or synthetic. You would think, but wait till we finish the rest of the section.
There's a possibility that.
All right, so here, can I use synthetic? Yes, obviously I'm teaching you synthetic. My gosh. Do it. All right, -3 goes on the outside. Inside's listing of the coefficients. Dude, I haven't done one. I should have done one that had a placeholder, but I haven't done one yet. Make sure you do a placeholder if it needs it. So the coefficients here are 2, 1, -8, and 5. Tell me what I do first. Bring it down.
-6 minus 1 is -5. -3 times -5 gives you 7.
Look at you, Silas, and you said you weren't even going to do it.
I didn't know. I kind of like it now.
I told you.
I really like this.
Do or don't.
I'm waiting.
No, this is easier.
I bet it's like.
So interpret.
This is going to be 2.
X minus 5x, 2x squared minus 5x plus 7 with a remainder of -16 over x plus 3. Can you explain this to me?
Now,
Fourth one.
I want you to think about what it means to be a factor. Because remember, this is all about division, and factoring is what we always come back to. If I gave you the number 6, and I said a factor of 6 is 2. Could you give me another factor based on that? 3, right? Then you know if a factor is 2, then another one would be 3. How did you get that if you didn't already know? You divide. Do we agree? So would you agree if I told you that when you divide by a factor, you get another factor? Would you agree with that? And would you then agree that if I took those 2 factors, the one that I started with, and the one that I was given and multiplied them together, you'd get what you started with, right?
Okay, I was writing down.
In other words,
Equals what you started with.
I started with 6. If I divide by 2, I get 3. That tells me two things. That tells me that 2 and 3 are both factors, but it also tells me that 2 times 3 would give me 6. The two factors multiplied together give you the original. Okay, so these are some theorems that we talk about. Let's say, I'm trying to think which one I want to do first.
How do you know with that thing you just did, how do you know when to use it?
When you're dividing. Oh, x plus a number or x minus a number is the only time you can use
So
it.
when there's not a
No coefficients, no exponents, just x plus a number or x minus a number. Okay? Tell me what else happens when you divide by a factor? What's always going to be true when you divide by a factor?
you always get a whole
Yes. Which means you get no what?
Decimal.
Remainder. Okay? You know how some of these we're getting a remainder of 0? If you divide by something, if you get a remainder
Oh, I think I know.
of 0, then that means you found a factor. Okay? And we're going to kind of build on that. Do you have a temperature? I thought you might. I'm sorry. I hope you feel better. Ah! What happened to mine? Okay? In other words, when I took that 6 and I divided by 3, I got a whole number, no remainder. That means this is a factor, even if I wasn't sure that 3 was a factor, okay? Those are the two basic concepts for factor and remainder theorems. When you divide by a factor, 1, you get no remainder, but 2, you get another factor. I hope you feel better, Tatiana. Okay? So, we're going to look at 2 scenarios to use these 2 theorems. Y'all ready? Scenario number 1. We're going to factor completely given a factor. I should do this as like Roman numeral 1 so I can do some little steps beside it. Kiana loves the steps, right? There we go.
Completely.
That says completely, y'all. Completely.
I've seen I've seen it. It's just this.
I thought y'all couldn't read my writing again, which happens often.
It's just my wrong.
Let's say I gave you a polynomial. F of x equals 3x to the third minus 4x squared minus 28x minus 16. And I said factor that completely. Would you know what to do?
Yeah.
What? Looks like, well, but it looks like I might could group it, right? I'd try to group it. But if you tried to group it, you'd be sadly disappointed because this, in fact, will not group, right?
Take out the GTF.
There's no GCF.
I feel like that's what would happen every single time on the test.
Okay, so let's say I've given this polynomial mass to factor completely. I've utilized all my resources. I cannot factor it. But what if I said factor it completely if you know that x plus 2 is a factor? Now could you possibly factor it completely? Because what that means is, that means that x plus 2 times something else gives me f of x.
So you just divide it.
So you just divide it, okay? So your first step is to divide by the factor. And you're absolutely right. I would just do it synthetically because that is absolutely the easiest way to divide something like this, okay? So when I divide synthetically, -2 on the outside, yes? Inside, I have 3, -4, -28. Now, if you get a remainder here, you've done something wrong, because remember, if it's a factor, it doesn't have a remainder, right? That's the definition of a factor. All right, drop the first. Multiply. Okay.
Just because I want to try to.
No, do it.
3 is the same. -48 times. Drop it down.
You keep doing it. Don't look up. I'm not going to tell you.
Yeah, that's what I got. That's what you're supposed to be doing. Because you're not supposed to have a remainder.
Oh, that's right.
Yeah.
So we did it.
Once I find out I get that part, I'm good.
Okay,
Once I get
wait.
the X plus 2.
Keep doing it.
Wait, so. Wait, where did the x plus 2 come from?
Oh my God.
It was given to me because I couldn't factor it the way it was. So
It's okay, Palmer.
I threw you a bone. I said, here's a factor. Now can you finish factoring?
I'm so
All right.
Wait, it
So-
doesn't work.
Yeah.
to better understand what I'm doing.
Well, you should have got 0.
All right. So look, this other piece that we talked about would be here. X plus 2 times something would be 3x squared minus 10x minus 8, right?
Oh.
Okay. So what I've done for step 2 is I've written it as a multiplication problem. Multiplication. So it's now x plus 2 times 3x squared minus 10x minus 8.
I thought you multiply and add.
You could multiply it, huh?
Wait,
I did.
So -2 times 3, now I thought you did 3 times 6.
-2 times 3 is -6, and then you add those,
Yeah.
and then you multiply.
Oh, I thought you do.
Always by the outside number. Always by the outside number. All right, I'm not done yet, because what did I tell you to do in the beginning? Factor completely. But at this point, you should be able to factor completely, yes?
Yeah, because you can.
Because now look, I know how to factor a quadratic. We are quadratic factoring pros in here, right? Yes, we are.
We'll just say that.
We are. And, all right, so now I'm going to finish factoring completely, because at this point I can. Okay, the x plus 2 is just going to stay. It's a factor and it's there. When I multiply when I factor 3x squared minus 10x minus 8, multiply the ends. What multiplies to -24 but adds to -10?
What'd you say?
Multiplies to -24 but adds to -10.
6 and 4.
Those won't multiply to negative, which is 12 and 2, so it's -12 and +2.
And then we do this.
And now we just factor, yep. So I take a 3x out of the first two, and I take a 2 out of the second two. Remember when I told you that factoring would never ever go away?
Oh, I see that.
Huh. So factored completely, and this looks worse than what it is because I'm essentially doing what I already did in chapter 1. The only new part here is the dividing at the beginning. All right, so x minus 4 and 3x plus 2. I forgot to hit record. In your homework, it'll say given f of x and a given factor, factor completely. So I'm going to tell you that x minus 4 is a factor. Now factor it. The semicolon just means that doesn't go with the f of x. The semicolon, yeah. This is a factor. This is a factor. Now factor the polynomial completely, given that you know x minus 4 is a factor. Okay. So the first thing we want to do is set it up to what?
4.
Yeah, so what are you doing? Y'all was telling me, but you're not telling me what you're doing.
Oh, I'm just right.
What's 4?
4,000.
No, what's your step 1? Thank you. Dividing by the factor, right? We're going to do this.
Skip forward.
Okay? If you're a long division person, long divide it. But those of us who like the shortcut are going to do the shortcut. I'm going to put the positive 4 on the outside and list the coefficients here. 1, -1, -22, and 40. Drop it like it's hot. All right, multiply. Coefficients here.
Oh, so you just wrote them all.
Yeah.
I'm ready like that.
Drop it, multiply, and add. Multiply. I feel like I'm 80s aerobics. Multiply and add. Multiply and add.
How'd you get the -10 right there?
That's true though. You
-22 plus 12.
You're right.
should tell other people. I was like, take a deep breath.
And multiply and add. Okay, so I know I've done it correctly because the remainder is 0, right?
Yes, ma'am.
All right, so write it as a multiplication problem. This tells me that x minus 4 times what? Yes, yes, right? But my directions were to factor completely, so now I need to look at that quadratic. Does it factor any further? This is an easy one because the leading coefficient is 1. Yes, what multiplies to -10 but adds to +3?
-2 times 5.
-2, wait. Yes, -2 and 5.
-2 times 5. You gotta multiply.
Now, I'm going to use...
right?
Good job.
Wait, how do you just write it like that?
Do it with you.
Because when the leading coefficient is 1, whatever multiplies to -10 and adds to 3, those are what goes here.
It doesn't matter what you do.
If you grouped it and wrote it out, that's fine. It's just a shortcut. Remember we talked about a shortcut if the leading coefficient is 1. All right. I'm going to use this example to build up for the next concept, okay? If I were to solve this, in other words, find the x-intercepts if it equals 0. What would they be? Tell me what they would be first. 4, 2, and -5. Do we all agree with that?
Yep.
Look at what you did in the very beginning. You divided by, what's the relationship? What is what? They're factors. You're exactly right. Good job, Silas. They're factors. The zeros are just factors, right? So, but it's opposite signs. So, because all of these are factors, right? So, what if instead of giving you a factor, I said, hey, guess what? X equals 4 is a 0. Find all the other zeros.
No, I'm not doing that.
Well, but you just did. Because essentially what that means is if x equals 4 is a 0, that means that x minus 4 is a factor. And you know how to factor completely given a factor. Right?
No.
Yes. So,
They said I'm not.
so here's your number 2. Find all zeros given a 0. Okay? If you're given a 0, you're given a factor. That's what you have to understand about it, is that if you're given a 0, you're also given a factor, if you understand the relationship there. So, for example, let's say I have f of x equals x to the third minus 2x squared minus 23x plus 60. And I said that x equals 3 is a 0.
Oh, man.
Okay.
Would I still try to solve it the same way?
My steps are going to be exactly the same. Yes, it's going to be exactly the same. The only difference is the first thing I have to do is I have to define that factor. Okay? So, define the factor as x minus whatever that 0 is. Remember, it's the opposite sign, because when you set it equal to 0 and you solve it, the sign changes, right? X plus 4, the 0 is negative 4. X minus 2, the 0 is positive 2. So it's the opposite sign of what's there. So here, my factor for this, if 3 is a 0, then what's the factor?
X minus 3.
X minus 3.
And then we just solve it.
And now we do the same thing we did before. So we're going to factor completely. Well, how in the heck do I factor completely? Well, I've got a factor to start with, right? So the first thing I need to do is divide first.
Are you lost tomorrow?
All right, what goes on the outside? Some of y'all are just working so fast ahead of me. All right, 3, you're just doing it. What goes? So now I'm going to put, if you do it beginning to end, it just flows. It makes sense. All right, so I'm going to put my coefficients here. And my steps are now exactly the same as they were on the one before, right? Drop it, because it's hot. No, I'm just kidding. Multiply, multiply, add, multiply, add. I know I've done something correctly because the remainder at the end is 0. Okay. Write it as a multiplication problem. So x minus 3, remember I defined my factor to start with, times, what was it times?
X squared.
X squared.
Minus X.
Eh.
Or plus X.
Plus X.
Minus 20.
Okay? Factor that.
I don't know.
Well, this one doesn't have a leading coefficient. The leading coefficient's 1, so it's an easy factor. What multiplies to negative 20 but adds to 1? 4 and 5. Positive 5 and negative 4. Now, the problem didn't ask me to factor completely, although I have to do that to finish it. The problem asked me to find all zeros.
Which is positive.
Positive 3.
So now,
5 and positive 4.
I just solved. Yes. Now, yes, now that's it, okay? All right, understand there's 2 main scenarios we talked about today, okay? There's factor completely given a factor, okay? When you factor completely given a factor, and I'm going to come back to this, and I know some of y'all are still copying. When you factor completely, please don't be so slow about this. When you factor completely given a factor, see that blue circle of death? Okay. It waits and waits and waits. It makes me wait on it to decide to go to the next slide or the previous slide. Core guys. Factor completely given a factor. Notice the biggest thing that students have trouble remembering is the sign changes when you divide here. Okay? When it's a factor, okay? You take the opposite sign of the factor. But when you're given the 0, because the signs are opposite for zeros and factors, when you're given a 0, you keep the sign the same when you divide.
I'm so unbelievably confused by 0. Yeah.
Okay, so 0 is another word for x-intercept.
So if it's like x equals negative 3, then 0 would make it a positive 3?
Where are we done?
0 stays the same. The 0 stays the
Wait, so
same.
there can be 3 x-intercepts?
What's that gonna
It could
be?
be an unlimited.
Is that gonna
Remember, some of them you found 5 for.
Oh, it's gonna make the question